So, do you have strong basic math skills? Well, hopefully so. But if you could do this problem, that's a good indication that, in fact, you are pretty good in basic math. Now, of course, this particular problem isn't going to test all aspects of basic mathematics, but it's an interesting problem. And actually, there's some nice opportunities to make some common mistakes here. So, if you want to kind of check to see, in fact, if you do have pretty strong basic math skills, go ahead and pause the video and do this problem without the aid of a calculator. So let's go ahead and take a look at the problem. It is 5 halves plus 1/3 over, or being all this being divided by 5 halves. What is this equal to? Well, a lot of you might look at the problem and go, oh, this is easy, I'll do it right. But you never really know if, in fact, you're going to do a problem correctly unless you try, right? But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning mathematics as easy as possible. So if you're struggling in math or just want to learn math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. So the first thing is, let's just look at the problem, okay? And anytime you start a math problem, you shouldn't just look at the problem and say, okay, I know what to do, and just start doing work. That's the worst thing you can do, because you want to kind of collect yourself, take in the problem and say, all right, what do I got going on here? And kind of get your brain to review the situation. Okay, do not just start writing stuff. Think, and your thinking time before you actually start a problem could be all of 10, 15 seconds. But what you don't want to do is think about a problem for like 1 or 2 seconds and then like start working. Okay, so try to learn some patience here, and let's go ahead and take a look, first of all, at what we need to do, and then I'm going to highlight a common mistake, very common mistake in mathematics. All right, so we have a fraction. Okay, so we have to, first of all, obviously notice that we have one big fraction bar, and we have some stuff going up here in the top, which is the numerator, and then we have some stuff down here in the denominator. Now, fractions, this is really division. This little fraction bar is division. So really, this is like a division problem, okay? Now, before we kind of combine all these fractions, what we're going to have to do is simplify this numerator stuff right up here, okay? And a good way to look at fraction problems, or I guess basically fraction problems where there's one big fraction bar and there's a lot of different stuff going on in the numerator and the denominator, is to effectively think of whatever is going on in the numerator or denominator as two separate problems. Okay, in other words, you want to simplify everything in the numerator and everything in the denominator, and then after that, then you can kind of continue on and do what you have to do. Of course, I'll show you all of that in just 1 second. So that's the kind of the first step here, is to say, all right, what do I need to do? All right, I got a fraction problem. Let me go ahead and just treat the numerator and denominator as separate problems. So obviously we're going to have to add 5 halves and 1/3. So we need to know a little bit about adding fractions. Okay, now let me go ahead and highlight a very, very, very common mistake. Okay, so you see we have 5 halves here and 5 halves here. I can tell you right now, many of you said, oh, you know what, I think I could cross cancel these and just cross cancel like that, okay? Now, this mistake happens over and over and over again. Matter of fact, I'm going to highlight this error in a few different ways. Let's look at an algebra example of this mistake, because I think it's a little bit easier to see. What if I had x plus y over x? Okay, so for those of you that know some basic algebra, you might look at this expression and you'd be like, wow, this x and this x, it looks like we can like just, they looks like they just want to be cross-canceled. And, if I told you to simplify this, you might, some of you, a lot of you would just put y, okay? Now that's totally wrong, okay? Let's take a look at another example of this, and I'll show you why this is wrong right now. So let's say I had 2 plus 7 over 2, okay? Now right here, you might be saying, well, here's a 2, here's a 2. Can I just cross cancel these 2's? And if that's the case, the answer would be 7, right? Certainly, it looks like these 2's want to be cross canceled. But really, indeed, what is the answer here? Well, the answer is 2 plus 7 is 9, and then we have 9 over 2. So this is the actual correct answer. It's not 7, okay? So we cannot cross cancel. So what's going on here? Where's the confusion? Well, let me go ahead and show you the confusion right now. So what happens is a lot of students forget when the difference between a sum or a difference and a factors. Okay, so let's suppose I had the fraction 14 over 2, okay, or 14 divided by 2, of course, is 7, right? So we all know that 14 divided by 2 is 7. Now 14, the factors of 14 is 2 and 7. Okay, these numbers here are separated by multiplication, i.e. these are factors, okay? Not 2 and plus 7, this is not factors, this is just a sum, all right? Now when you do have common factors, you can cross cancel just like that, and the answer would be 7. So what ends up happening is a lot of students, I think because they might be going a little bit quick, or maybe they just didn't know. They look like, oh, these look like factors. Maybe I can cross cancel these like this. It leaves me with y. Okay, that's not the case, right? So algebraic an algebraic example of this again would be x times y. Of course, we wouldn't write that that way. We would write it like this, xy, like so. And here you could cross cancel. You're left with y. All right, now I really kind of spent some extra time on this error because it's so common, and hopefully some of you actually made this error with me, and that's great because now you're like, okay, I'll never make that mistake again, right? So this is a common error, and this little explanation that I gave, to really drill down, and review it, is appropriate because you got to think of who's telling this. For me, I've graded how many test quizzes, homework, maybe like 10 million, a lot of papers, right? Decades and decades and decades and decades. You see the errors, and this error I've seen over and over again. All right, so not to belabor that, let's continue to move the problem forward. And the first step is we're going to now have to focus in and add these fractions right now. So let's go ahead and talk about that. So that's 5 halves plus 1/3. Pretty basic fraction stuff, right? Now, for some of you that have seen some of my other videos on fractions, I'm not the biggest fan of writing fractions with the angled fraction bar like this. There's nothing wrong with it stylistically, but I want you to get in the habit, if you do write your fractions this way, to write them this way. It's just going to be much better for you, especially in algebra. So we'll use the horizontal fraction bar like this. So we got 5 halves plus 1/3. Now, we want to add these fractions, but can we add these fractions right now? No, we cannot because the denominators are not the same. Okay, these numbers down here are not the same. So if I had a situation like, let's say, 2/7 plus 1/7, I can add these fractions because the denominators are the same. Okay, so what I need to do is simply add the numerators and put that over the denominator. So 2 plus 1 would be 3/7. Okay, so this is how we add and subtract fractions. So in this situation, we do not have common denominators, so we're going to have to find the lowest common denominator. And let's go ahead and get into this right now. So if you need help with fractions, okay, and this is another very common area for people, they just don't know fractions as strongly as they think. Matter of fact, when people see fractions, the typical facial expression is like, fractions, I don't want to deal with fractions, I hate fractions. You got to make friends with fractions. It's not that bad. But let's go ahead and get into this problem here. So the first thing we need to do is identify the lowest common denominator. And one simple way to think of the LCD is, what is the lowest number that both of these numbers go into? Okay, well, that would be 6, right? So both of these numbers go into 6 without a remainder. So to find the LCD, this is a whole topic, a separate discussion. It's pretty easy to find the LCD right here, but if I gave you these fractions, let's say the denominator was 208 and this was 356, then a lot of you would just be like, I'm not doing this anymore. Matter of fact, I'm going to leave this guy and unsubscribe to his YouTube channel. Well, don't do that. But I am telling you that just to find the LCD is, a whole separate discussion. So if you're struggling with fractions, a lot of people are. Let me recommend a couple quick things to you. One, I have a ton of additional videos on fractions on my YouTube channel. And two, you may want to check out my Math Foundations course. It's a great little mini basic math course. I'll leave a link to that in the description of this video. But anyways, the LCD is 6. So what does that mean? Well, it means that we're going to have to rewrite both of these fractions such that the denominator is 6. Okay, so we're simply just going, we're not going to break the fractions or change the value of them. We're just going to rewrite them such that their denominators is 6. Okay, then that way they'll have a common denominator. All right, so how do we do that? Well, pretty easy. So we're going to take a look at our fractions here. So here, our denominator is 2. How can I turn a 2 into a 6? Well, easy. If I multiply it by 3, it becomes a 6. But if I multiply the denominator by 3, I also have to multiply the numerator by 3. So 3 times 2 is 6, and 3 times 5 is 15. So our first fraction is 15 over 6. Okay, so how do I change this 3 into a 6? Easy, just multiply it by 2. So 2 times 3 is 6. But if I'm going to multiply the denominator by 2, I also have to multiply the numerator by 2. So 2 times 1 is what? 2. So our fractions now are 15 over 6 plus 2 over 6. These fractions here are equivalent to our original problem. Okay, they're only different in the sense that their denominators are now 6. Okay, but if I asked you to reduce these fractions right here, say, hey, simplify these fractions, simplify 2/3, you'd get back to 1/3. Okay, all right, so now here we have common denominator 6. So we just write that one denominator and add the numerator. So 15 plus 2 is, of course, 17, or 17 over 6. Okay, so that is kind of like our first major step that we need to take to do this problem. After we realize that we can't cross cancel the 5 halves. So now we have 17 over 6. Now, this was not a lot of work to add these fractions, but so many students, they just hate dealing with the LCD, and I'm sure I was that way back in the good old 1970s and 80s. I was like, I don't want to do this stuff. Well, I want to show you an awesome little shortcut to adding and subtracting fractions, just in case your brain does not feel like thinking. You're like, you know what, I want to just take a shortcut. Well, I'm going to show you that shortcut right now. But before I do, I want you to take a shortcut and not even think about the answer. Just go ahead and subscribe to my channel and hit that notification button. You have no idea how helpful this is for the growth of my YouTube channel, which of course I am trying to grow this. I've been on YouTube for a long time. I look at anyone and everyone who watches my videos as my students, okay? And I'm trying to teach you math. Of course, you wouldn't be watching this if you weren't interested in learning mathematics. But real quick, if you're new to my channel, I cover basic math to advanced math like calculus and everything in between. So hit that subscribe button, and I'm pretty sure my facial expression will be just like that. Now back to the problem. Okay, so I told you there is a great shortcut to add and subtract fractions, all right? And this shortcut, and again, this is stuff that I teach on my YouTube channel, and you'll find it in my math courses. I call it the bow tie method. This is an absolute must know. Okay, you must know this method, especially for algebra. So here's the problem. Okay, this method works for any fraction problem for addition and subtraction. Anytime you need to find the LCD, also works in algebra. So it's an awesome method. So let's go ahead and take a look at how it works. So to add or subtract any two fractions, you're going to follow this very specific pattern. Okay, so there's no LCD involved. You don't have to think about that. And let's go ahead and take a look at this pattern. So you're going to start in the bottom right, okay, right here, this denominator here, and you're going to multiply going this way. So I said the bow tie method, right? So for those of you that don't know, and let me just kind of draw a little bow tie. A bow tie is one of these little things like that. So this is the kind of pattern that you want to be thinking about, right? So you're going to be starting in the bottom right, and you're going to multiply across to the top left, okay? So in this case, it's going to be 3 times 5, which of course is 15. So this is going to be building our numerator. Okay, so now you're going to switch to the bottom left. Okay, now you're going to multiply across the other way. So 2 times 1 is what? 2. Okay, now this is an addition problem, so we're going to put a plus just like that. Okay, this is forming our numerator. Now to get our denominator, all we need to do is multiply across. So we're going to go from 2, or from left to right. 2 times 3 is 6. And there you go. This is our denominator. Okay, so you can see 3 times 5, 15, plus, right here, plus 2 times 1, 2, over this whole thing, over 2 times 3 is 6. Take a look at this. 15 times 2, 17 over 6. 1, 2, 3. No LCD, no thinking. Just like, wow, that is amazing. Okay, so for those of you who have never seen this method of adding fractions before, again, this is like a 100% must know. You got to put this into your long-term memory. It's probably one of the most useful math tricks, math hacks that I know of in all of mathematics. Okay, so that's just another way to find the answer to adding these two fractions. So now we have to go back and put this into the problem. Okay, so looking at this problem, right? So the first thing is we're looking at it, we're like, all right, thinking about it, we're definitely not going to cross cancel. That's going to be bad if we do that. That's not correct. So we have a complex fraction. We're going to have to do this. Okay, there's nothing to do down here, but we're going to have to add these fractions, which we did. So now we got 17 over 6, that being divided by 5 halves, right? So basically a complex fraction. But remember, the fraction bar itself is a division symbol. Okay, so this is 17 over 6 being divided by 5 over 2. All right, so this is the way you want to think about it. Okay, so 17/6 divided by 5 halves. We're going to write it this way. So I have my numerator, 17 over 6. Again, I'm switching over to these horizontal fraction bars. So 17/6 divided by, that's the fraction bar again, 5 halves, just like so. All right, so now the question is, do you have knowledge of how to divide fractions? Okay, so we got all kinds of good stuff going on in this problem. We got opportunities to make, common mistakes, complex fraction, adding fractions, LCD, and now we get into dividing fractions. Let's go ahead and talk about how to divide fractions. Division of fractions is very, very easy, okay? The key is we really don't divide fractions per se. What we're going to do is change this division problem into a multiplication problem. And the way we do that is we take the fraction to the right of the division symbol. Okay, so here's the division symbol. The fraction to the right of it is 5 halves. And what we're going to do is we're going to go from division to multiplication, and then you're going to flip this fraction upside down. So 5 halves becomes 2 over 5, okay? So we're going to go from division to multiplication by flipping the fraction to the right. Okay, so now we're going to do this problem here, 17 over 6 times 2 over 5. Let's go ahead and take a look at how to do this. It's super easy. So when you're multiplying fractions, all we need to do is to multiply the respective numerators and denominators. Okay, so in this case, it would be 17 times 2 over 6 times 5. Now, a lot of you might be saying, oh, let me go ahead and do this multiplication, and get the answer. No, no, no. Do not do this just quite yet. Remember, we're doing this problem without the aid of a calculator. So these here, remember, these are factors, okay? So unlike our original problem when I was making that case where, hey, when you have sums and differences, you can't cross cancel. We have factors here, anything being separated by multiplication. This is a great opportunity to simplify the problem before we have to multiply this entire thing out. Okay, so let's go and take a look at how we can do this. So we have 17 times 2 over 6 times 5. So some of you, it all depends on, how you were taught fractions. A lot of you can say, oh, 2 goes into 6 3 times. And that is great, okay? So that's kind of like um, we call cross canceling. Okay, that's fine. But let's talk about what's really going on here. So we have 17 times 2 over 6 times 5. Well, 6, I can look at the factors of 6. As a matter of fact, I can think of 6 as 3 times 2. All right, so here's 6, 3 times 2 times 5, right? But I have a 2 here and I have a 2 here. So here I have like factors. 1, 2 could cross cancel with this 2. And what am I left with? Well, all I'm left with is this 17 up in the numerator and a 3 times a 5 down in the denominator. So now, in terms of the multiplication, all I have to do is, well, 17 times 1 is 17, and 3 times 5 is 15, right? I didn't do any like big multiplication up here. I didn't say, okay, 17 times 2 over 6 times 5. I would have gotten a larger fraction here. Then I would have to reduce that fraction. Remember, in mathematics, you always want to leave your answer in its simplest form. That's not like really an optional thing as well. Okay, your teacher, if you give your teacher your final answer and it's like 100 over 300, okay, your teacher would be like, why couldn't you just write that as 1/3? And they might even give you like a couple points off, and then you're going to be very upset. You're going to be like, what are you doing, Mr. Math teacher? I got it right. Just because I didn't reduce it or simplify it. Well, listen, again, I'm telling you these things in advance. One of the things I love, doing in my YouTube videos, as a matter of fact, in all my videos, is really sharing my best tips, especially for those of you out there that are math students. Okay, just really, it's so easy to get an A in mathematics if you know the common mistakes to follow and you know the kind of right, basically what your math teacher wants to see. I'm not saying it's so easy because you definitely still have to put in the work, but you can make it as easy as possible, right? And it all starts with clear and understandable instruction. And that's hopefully what I'm delivering to you. So, again, if you need help with fractions, get the help that you need. I have a ton of material on fractions, again, on my YouTube channel and in my Math Foundations course. So, you can explore all of that. But, anyways, with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.